Don't drink from the puddle, Ivanushka, you'll become a kid. This Russian fairy tale tells us what could happen if you drink contaminated water. And this situation is very close to what is going on during our Congress, which is convened during pandemic. But my report deals with a new and very different source of water contamination. This source is solid waste landfills that provide discharge of contaminated water into natural water sources like wells and rivers. The name of our report is Treatment of Municipal Landfill Leachate Using Low-Pressure Membrane Techniques. I am Alexei Первов. I am Professor of Water Supply and Sanitation Department of Moscow University of Civil Engineering. Landfill construction is a common and conventional solution for the municipal waste disposal and storage. But landfill leachate, which is drained from the landfill body, creates a significant threat to the surface and groundwaters as it contains organic and inorganic contaminants generation within landfill body. Different methods are applied to remove these contaminants from water, such as chemical and biological techniques. But to efficiently remove dissolved salts and biogenic elements, such as ammonia and phosphate, reverse osmosis techniques, membrane techniques are applied. In commercial common practice of using reverse osmosis in landfill leachate treatment, recycling of concentrate applied, whereby concentrate stream is returned back to landfill body that increases amount of water to be treated. High organic content increases osmotic pressure and decreases membrane permeability. From this point, chemical treatment removes organic and it is useful for membranes. But from the other point, chemical treatments such as coagulation, flocculation, and further sediment techniques enlarge footprint. Therefore, the goal of the present report was to provide experimental results to develop efficient membrane techniques and to evaluate the required membrane area and to reduce operational costs, as well to reduce concentrate flow rate. Often, a double-stage or even three-stage membrane treatment unit is required to reach low concentration values of nitrate and ammonia in the product water to meet very strict discharge regulations. As concentration values of ammonia in the leachate vary from 80 to 2000 ppm, thus two stages of reverse osmosis membrane unit were applied. When landfill leachate is purified using membranes, the problem of concentrate handling and its utilization arises. Concentrates flow usually constitute from 15 to 13% of leachate used as a feeder flow. As it was mentioned above, concentrate is returned back to landfill body, and this causes increase of all contaminants concentrations with time. In our report, we are going to present a new technique to radically decrease concentrate flow to the amount less than 1% of the initial feed flow that enters membrane unit. Concentrate can be utilized together with dewatered sludge, as it is shown on this diagram. The dewatered sludge with 80% moisture can be further utilized using vitrification, incinerations, or other techniques. To reduce the produced sludge ecological hazard, a new approach is presented that consists of separation of concentrate flow into three different streams: the concentrated organic solution, concentrated ammonia solution, and multivalent ion solutions such as heavy metals, sulfates, calcium, that can be utilized separately. The present study demonstrates results of experimental evaluation of reverse osmosis characteristics to treat leachate and to reach high quality of product water and minimal value of concentrate flow. A test unit flow diagram consists of membrane module, water tanks for leachate and purified water, and the pump. First of all, dependencies of various ions concentrations values on the recovery value and the value of volume of product water were determined. Produced during 1 hour in the certain range of changes of coefficient K, and using the obtained values of average specific membrane flux within this range, it was calculated the required membrane area to produce the required amount of produced water during 1 hour. The required number of commercial membrane elements used in membrane facility can be determined assuming that membrane area in the standard 40-40 element equals 10 square meters. Thus, to decrease wastewater flow, for example, by 7 times, and to produce 1000 liters of quality water per hour, we need 12 elements of 40-40 standard. The K value grows step by step. Therefore, membrane elements should be connected in series in parallel, 5 in parallel, 4 in parallel, and 3. Both cases on landfill leachate treatment without chemicals using direct reverse osmosis and with chemical pretreatment are evaluated in the article. For the case when leachate was not subjected to chemical treatment and is directly purified with reverse osmosis membranes, the first steps recovery did not exceed 95–96%. due to membrane dramatic loss of membrane permeability. For the case when chemical deposition of organics is applied, leachate disposed of organics can be treated more efficiently with higher recovery when concentrate flow is less than 1% of the initial flow of feed water. In this case, concentrate can be removed together with the water sludge after sedimentation and dewatering of removed organics. But high chemical consumption is required as we use stoichiometric amounts of chemicals that increase operational costs. To reduce the ecological hazard of the sludge, concentrate can be separated into 3 different streams, then can be further utilized. The concentrated organic solution, the concentrated solution of ammonia and sodium chloride, and multivalent ions concentrate such as heavy metals, sulfates, calcium and iron. These streams can be utilized separately, either with municipal wastewater sludges or moved to special storages like galvanic industrial waste. As a result, the landfill leachate is separated into pure water stream and the sludge. And the sludge could be used for future landfill recultivation as it could be turned into the soil to make the environment around us ecologically safe.